Good day everyone, I am Mariene Soverano and for today's video I'm going to discuss Module 5 entitled Work and Energy. We know that work is defined as action done on an object that displaces the object. W is equal to Fd or work is equal to magnitude of applied forces times the displacement of object. While energy is the capacity to do work, and this is the summarize of work energy theorem. Work is done an object, there will be change in kinetic energy. Now let's go for our lesson 1 entitled Fundamental Work Energy Equation for Rectilinear Translation, Article 14-2. The mathematical expression defining work and kinetic energy as applied to translation are easily obtained by considering the following equation, which have been already derived. In this equation, the sum of x is equal to W over G A, EDS is equal to BdB, and this is the group of equation of A. We know that kinetic energy formula is K is equal to 1/2 mv squared. M stand for mass in kilogram and B stand for velocity in minutes per second. In first member of equation A, equate the resultant force acting at any instant to the corresponding acceleration. Obviously, ang value sang A nakadepends sa corresponding value sang sum of x. It may be constant or variable, depending on the sum of x is constant or variables. While the second member of equation A are expressing the instantaneous value of the acceleration in terms of the instantaneous velocity. When we say instantaneous value, ito yung mga biglaan. And when we say instantaneous velocity is a vector with dimension of length per time. Eliminating A in the two equations result in sum of x multiplied by ds is equal to W over G BdB. Dito sa equation A, kailangan lang natin i-eliminate yung A. Eliminate natin to and ito na magre-result ng ating equation B that defines as the differential form of the work energy relationship. Assuming that the initial velocity is b sub o at zero displacement and the final velocity is b at the final displacement s, we may integrate equation B to obtain this equation of the integral of some limits of summation of x ds is equal to W over G integral of some limits of b dB, which give us the integral of some limits of summation of x times ds is equal to 1 over 2 W over G B squared minus 1 over 2 W over G B sub O squared is equal to W over 2G times the quantity of B squared minus B sub O squared. This is the equation of 14-1, and this is the fundamental work energy equation. The expression of integral of some limit summation of x multiplied by ds is defined as resultant work, whereas the expression of 1/2 W over G B squared is defined as kinetic energy. In other words, ang equation 14-1 may be now interpreted as the meaning of the resultant work on a translating body nga iga-equal sa corresponding change sa kinetic energy. Work energy equation for constant forces. If the forces acting on a body are constant, the resultant force of summation would be constant. Hence, equation 14-1 becomes summation of x times S is equal to 1 over 2 W over G B squared minus 1 over 2 W over G B sub O squared is equal W over 2G times the quantity of B squared minus B sub O squared. And this is the equation of 14-2. So, the expression of sum of x S is called the resultant work done on a body at its move through a linear displacement S. Units. Substituting the dimensional units of the terms in summation of x multiplied by S, we find the units of work to be force multiplied by distance. Express ang force in pounds kag ang distance in feet. The unit of work is feet to lb. Other dimensions sang units can be used kag ang work can also be expressed as lb to inches, dyne to centimeter, tan to feet at marami pang iba. Usually, it is convenient to express force in pounds, distance in feet, and time in seconds. I-substitute ang ini nga units in 1 over 2 W over G B squared give the units of kinetic energy. So, the units of kinetic energy must be 1 over 2 W over G B squared is equal to lb over feet times secant squared times feet squared over secant squared is equal to feet minus lb. Thus, the work energy equation is seen to be dimensionally correct. This is a check of the validity of any equation. And that's all. Thank you for watching.